So this video is going to be on a basic thing you're going to do in trigonometry, although apparently some people in school they'll tell you it's geometry. But so ka sorry about that, Toa. SohCahToa. What do you do with that? How do you use that? That's a question that comes up, I guess. And so SohCahToa, it's kind of a memorization thing, although you do need to understand what it means. And you memorize the terms. It's really quite simple once you get the concept. And really, SohCahToa is just a tool to help you remember what to do. It's just a little thing to help you make it easier for you. So anyway, we'll erase that right now and explain the basic concept. First of all, SohCahToa only applies to right triangles. So this is an example of a right triangle. And it's called a right triangle because this angle right here, the angle from between this side and this side is 90 degrees. Or you could call that square. People call it square. Or you could say it's a right angle. So if you were to get a carpenter's square, and I have them outside, I could go grab one, but I'm not. It makes that right angle. All right, and a lot of things in life are square in shape. So, a square, an actual square, has all 90-degree angles. Okay, if it didn't have all 90-degree angles, then this angle, it would be coming off like this, maybe, and then that wouldn't be a square, right? Okay, or maybe it'd come off like this, and then if you connected that, that wouldn't be a square. All right, so a triangle, of course, has three sides, and for it to be a right triangle, it always has to have one angle that is 90 degrees, and that's how you draw that. That little square that you draw in there, it means that that's a square angle. When you draw a little square in there, it just means that this is a square angle, and that you can make a square with this angle, because this angle right here that forms the triangle could be the angle of a square, and that it's 90 degrees. Here's a little tidbit of information. Any triangle, all of the angles will add up to 180 degrees. So on a right triangle, since one of them is 90 degrees, then let's say this one is angle A, this one is angle B, then 90 plus A plus B equals 180. Now, all the angles will add up. There's always only three, and they will always add up to 180 degrees. Because basically you're turning this way, you're turning that way, and you're turning back where you came from. So anyway, but in a 90-degree triangle, the other two add up to 180 minus 90, right? Because we could do this algebra right here, right? And we get A plus B equals 90. So in a right triangle, it's just one little tidbit of information. You have one angle that's 90 degrees, and then the other two will have to add up to 90 degrees. So they're both less than 90 degrees, but the sum of them is always equal to 90 degrees. So what you do with SohCahToa is you're using trigonometric functions, and we'll take a look at that. A trigonometric function is a function. So here's an example of a function. Function of x equals 2x plus 7. All right. Basically, you input something in for x, and then you get out the function of x. So if I was to put in 2 right here, then it would be 2 times 2 plus 7 equals the function of x, and which is 4 plus 7, which is 11. Okay? So a function is where you say, all right, this is what I have, and what does this translate into through, what does this function turn that into? Okay? So trigonometric functions, the main thing you're going to use these for with SohCahToa most of the time is going to be, what they're going to do is they're going to give you some question, and they're going to give you one side of the triangle. All right, let's say you have side A, side B, and side C. They're going to tell you one of those sides, and then they're going to tell you one of those angles. And a lot of times the angles, they'll use Greek letters. Theta, which is like a TH in English, just a Greek letter. It's nothing fancy, Or they might use, a lot of times they like to use phi, which phi just makes the same sound as an F in English. So it could just be F and TH. All right, and then of course this one's always the right angle, and it could be done different ways. Like you could do it like this, or this is the right angle, and you can see that we could do the same right angle, and we could theoretically we could have a bigger triangle that comes out longer like that, and then you know. So the length of this side, the length of this side, and the length of this side could be all kind of different lengths, and you can still have a right triangle, but that will change the angles. Okay, so here's the basic rule of thumb. What you need to know, like what they're going to do is they're going to give you one of the angles. They're going to say, let's say they give you this angle theta here, and then they give you this side, the length of side C, and then they don't tell you anything else, right? All you need to figure out the length of the other side is just one of the angles, and then one of the length of one of the sides, and it can be any side. But which side they give you and which angle they give you determines like which part of SohCahToa you use. So you use there's So, there's Ka, and Toa, and basically what they gave you tells you like, okay, well if they gave me this one, I got to figure out that one. If they gave me that one, I got to figure out that one. All right. They can also just give you two sides, like maybe they'll give you this side and that side. And then you could go work backwards and figure out like an angle from that. And of course, if they gave you this angle, you could just do 180 minus this angle and get the other angle, right? Okay. So let's just work an example. Let's say that they gave you this angle theta here, and they said theta equals 30 degrees. All right, and then they said, you know, I don't know, this side over here equals 4. And then they're going to ask you, like, what is this side length? Okay? Well, you would use SohCahToa to do that. All right, and so we'll erase this for now. We'll bring it back. But SohCahToa works like this. SohCahToa. All right, and think of it as like a separation, really. You know, these are where it capitalizes here. Maybe I could separate it out. They say SohCahToa like that, but think of it more like this. SohCahToa. Where the S in the first one stands for the sign, the function that on your calculator is sine, and it's like that. It's spelled like that, S-I-N, just to abbreviate it. It's called sine. It really means sinusoid, but it's just called sine. And then C would be cosine, which is, you know, like that on your calculator. And you just, these functions are complicated, but you just plug them in your calculator. It's not like 2x plus 7. It's like something real complicated function that you just don't worry about what the function is. You just input the inputs into the function, and then it spits out the outputs. And then the T is tangent, which is just T-A-N, tangent. Okay, so that's, you know, just something to memorize thing. You know, sine, cosine, tangent. That's trigonometry. Okay. If you're talking about sine, cosine, and tangent, you're talking about you know, trigonometry. Now you can also do, you got the sine, cosine, and tangent, but you can also do what's called arc sine, arc cosine, and arc tangent, which is basically where you take the sine, cosine, tangent function and you work backwards with it. We'll talk about what that is, but it works, instead of what you normally would put in and get out, you take the output and put that into the reverse function, and it gives you what would have been the input for the normal function. So you'll see that. But on your calculator, they don't write ARC for the sort of the reverse function. They write it like that: tangent to the -1, cosine to -1, and sine to -1. Okay. So anyway, we'll worry about that later. SohCahToa. So remember, this stands for sine, the C stands for cosine, and the T stands for tangent. And then this stands for, these other letters represent sides of the triangle relative to the angle. So let's go back to our triangle. All right, and we had theta here. O means opposite. So if you were to talk about, if you're talking about this angle theta, and you say the sine of theta is the opposite over the hypotenuse, which this would be the opposite side, and this would be the hypotenuse. Hypotenuse is a word, it means the longest side of the triangle. The longest side of the triangle is always opposite the biggest angle. And since the biggest angle is always the right angle in a right triangle, because the other two have to add up to 90, and this one is always 90, so these are always smaller than 90, then whatever one is opposite the 90-degree angle is the hypotenuse, and that's the longest side. So the sine would be, the sine function for this, let's make sure I'm in frame. I'll write it and we'll see if it's in frame. So like if we want to say what the sine of angle theta is, equals opposite divided by the hypotenuse. So if you were to take whatever the angle theta is, let's say it's 30 degrees. Make sure, can't really tell if that's in frame or not. I'm going to move the camera for just a second. Okay, definitely in frame. All right, good. All right, so the sine of, let's say it was the sine of 30 degrees. And I don't know, remember, that's what they asked us. They said, all right, if this is 4, that's the question. If this is 4, and that's 30 degrees, then the sine of 30 equals 4 opposite over hypotenuse. 4, so opposite over hypotenuse. 4 over hypotenuse. 4 over whatever the hypotenuse is. So now, if you take the sine of 30 and plug that in your calculator, it'll spit back at you a number. And that number that it spits back at you is the same number that you get if you take this side, the length of this side, and divide it by the length of that side. That's how the function works. So this will spit at you some number, sine of 30. I don't have a calculator right here handy to do it with, unfortunately. But that's the point. It'll spit some number at you. Okay? And then if you were to take 4 divided by whatever length that is, it would spit the exact same number at you. Okay, so that's why we know that those are equivalent. So like, but we don't know the length. We're trying to find out what the length of that side is. And so what we're going to do is take 4, and we're going to use algebra to get the h by itself. So what we do is we multiply this side by h and this side by h. And what that gives us is these h's cancel, right? And so you get h sine 30. And so these h's was cancel. And now you have 4 equals h times the sine of 30. And now you can divide this side by the sine of 30. And divide this side by the sine of 30. And these will cancel. And now what you get, h, the length of the hypotenuse equals the length of this side divided by whatever the sine of 30 happens to be. It'll be some decimal specific thing, just like if you were to take 4 and divide it by 7 or something. Okay, so there you go. That's a basic trig function. So you can see SohCahToa, the cosine of this angle would be, so like the cosine of 30, let's say that this length of this side, we'll call it, I don't know, let's call it J. J is a terrible one to use. We'll call it B. All right, so the cosine of 30 degrees, or the angle theta, right? We'll just use 30 just to make it simple for you. The cosine would be adjacent over hypotenuse. So you understand, opposite of the angle is the one directly opposite it. The hypotenuse is always the longest side. And then the adjacent one is the one that's not opposite and not the hypotenuse. So like, you know which one's opposite, you know which one is the hypotenuse, the longest side. So the adjacent one to the angle 30 is this B. So adjacent over hypotenuse would be B over H. The cosine of 30 equals B over H. Now the tangent is the other one. It's the one that doesn't use the hypotenuse. All the other ones use the hypotenuse. The tangent of 30 equals opposite over adjacent. So you know which one is the opposite, because that's kind of easier. When I was younger, that's how I always saw it. The easy one to figure out is the one that's opposite, directly straight out from it. So opposite is, 4 again. And then the adjacent, opposite over adjacent, toa, would be B. Okay? So that's how you would, so like, in some situations, you know, it depends on what they give you, which one you use. So like, let's say, what would be a situation where you would need to use the tangent? Let's say that they, you know, well, it could be simple. Let's say they gave you the length of this side, and you said, okay, well, and they wanted you to give them back what the length of that side is. Well, the tangent of 30 degrees equals 4 over b. And then you're going to do the same math we did before. So it would come back around. It would be b equals 4 divided by the tangent of 30. All right? But you got to use the tangent on this one, the tangent one, because you're not using the hypotenuse at all. So if you're not using the hypotenuse, it's always tangent. And then cosine uses the adjacent and the hypotenuse. And then sine would be the opposite in the hypotenuse. Okay? Now, let's look at the reverse ones. They're called the arc sine or whatever. But let's say they didn't give you the size of this angle. And you could use this angle and do all the same stuff. It would just be, you know, the other angle. All right. Let's say that they just said it was theta. And, I don't know, a classic triangle is the classic 3, 4, 5. So that just happens to work out. I just memorized that, you know, that is a real triangle in real reality. They gave you this, they gave you all the sides. Or let's say they gave you just 2 of the sides. Let's say they gave you this side, and they said, the angle, find out what angle theta is. Well, okay. All right. Now, instead of using the sine, cosine, or tangent, I'm going to use the arc sine, or the arc cosine, or the arc tangent. So it's called like this. Arc sine, you know, would be like for the sine. But on your calculator, it won't say arc sine. It'll say it like this. It'll say like sine raised to the -1, which means the same thing as the arc sine. And what that does is that's going to input the one thing and get it. It works in reverse. So if the sine of theta equals, oh, sorry, didn't write the theta. If the sine of theta equals the opposite over the hypotenuse, right? Then the arc sine of the opposite over the hypotenuse equals theta. You see how that works in reverse? So in this one, you take the sine of the angle theta, and then you get the same number as this divided by this. All right, well, if you take the arc sine, then you take whatever the number of that divided by that is, and it spits back out theta. Okay, so it works in reverse. So in other words, the sine of theta is some random crazy number that's the same as the opposite divided by the hypotenuse. The arc sine of that crazy number, that is the opposite divided by the hypotenuse, equals the angle theta. So if you have a 3, 4, 5 triangle, I'm pretty sure that the angle here is 30 degrees. Just, you know, memorize. So let's say, so the sine of theta equals 3 divided by 5. And they say, figure out what that angle is. Well, then you would do, on your calculator, you would say sine to the -1 of whatever 3 divided by 5 is. Some crazy number. It'll spit back out 30. Okay? Whereas if you did the sine of 30, you would get whatever 3 divided by 5 is. Does that make sense? So that's how that works. Basic trigonometry. If you have 2 things about a triangle, 2 sides, if you have an angle in a side, you can use SohCahToa and also the arc sine, arc cosine, and arc tangent, and you can just figure out all the stuff. All the angles, all the sides, you can figure it all out. All right, so like if they were to give you, you know, let's say they don't give you the 5, and they say figure out theta. Okay, well now you've got to do, which one is this? Which sides do you have relative to theta? You have the opposite, and you don't have the hypotenuse, but you have the 4, which is it's not the hypotenuse, and it's not the opposite, so it must be the adjacent, right? So you would do arc tangent of opposite divided by adjacent, which the opposite's 3, and the adjacent is 4. And then that would spit back out 30. Remember, on your calculator, it'll be, since they don't want to write that long word, they just put it like that on the buttons. it's just easier on the buttons. Although when you get to calculus, you'll find out that that's not really a good way because that means something else in calculus, so it can be confusing. But basically on the calculator, they don't want to write this longer word, arc cosine, arc tangent, so they just like abbreviate it with this little raised to the -1. Anyway, yeah, that equals theta, right? And then in this case, theta is 30. Okay, so there you have it. Hopefully that is all. Hopefully, you know, we are good to go. All right. Special thanks to the high school, the teenager in 9th grade, I think, who asked me this question. What is SohCahToa? That is what you do with SohCahToa, and that looks more like a rabbit than a hand.